here live again from the TM1 and Planning Analytics user conference here in Paris. We're on the final day, day 3 of the conference. And what better way to kind of bring this home in our last session, broadcasting live, than to bring the man himself, the inventor of TM1, Manny Perez. Thanks for spending time with us here today, Manny. Appreciate it. Yeah, I'm looking forward to this conversation because I want to ask you a few questions I think a lot of people are interested in knowing more about. And so hopefully people can get this, and maybe questions they always wanted to know but weren't able to ask you before, right? So the first one is, that I think everyone always asks is, so why TM1? Why the name TM1?
Why the name
the first
TM1?
one. Yep.
Well, the story is that we were getting ready for to launch a product at a PC conference, one of the very earliest PC conferences, in June of 1984, and we had to come up with a name for the product. At that point, we had a code name which we could use, and we started.
You had a code name? What was the code name? Do you remember?
Yes, it had a code name. It was called QPMC.
QPMC.
Don't ask me what it stands for.
Oh, okay, that's a good trivia question. All right. Okay, QPMC.
And we started looking at options, and every one that we came up with was taken, and then kind of in desperation, perhaps influenced by the fact that the original prototype for TM1 had been done on a mainframe using a language called TM1. That I said, gee, why don't we call it?
Or PL1, was it?
A language called, PL1.
Right.
PL/1.
Yep.
So that we came up with the name TM/1.
That's
Somewhere
right, you had
along
the
the line,
slash.
the slash was lost.
Yeah. What was the slash? Why the slash? Just because PL1 had a slash? Or?
Yeah.
Okay.
Right.
Fair enough.
I remember during those days, one of our associates that had a background in sales suggested using the name Cubics.
Cubics.
Or Cubex.
Uh-huh.
And I said, gee, that we can't use cube because a cube is 3-dimensional and TM1 does multiple dimensions. And as you know, nowadays, cube is the word that is used for that. So, I mean, if I had to do it over again, I would have chosen something along those lines.
Okay. So the name CubeWise isn't offensive to you, hopefully, right? So. Yeah, okay. Nice one. Okay, so TM1 was kind of, naming is never easy, so you had to come up with something to brand it when you went to this show.
Right.
Right.
Correct.
Okay, fair enough. But so it wasn't like that you were sitting there having to patent the technology or something and come up with the name at that point, or something like that?
No. No, it wasn't a question of patenting. It was a question of copyright or trademark.
Trademarking.
It's a trademarking issue, and we wanted to get something that could be a registered trademark. And in order for that to work, it has to be unique. There cannot be other people with a similar name. And then, as it turned out, we applied for a trademark, and it was rejected because there was some obscure little company in Chicago that had a product called TMI or something, and the office felt that it was too close, and it got rejected. But anyway,
okay.
That's
okay. Another question. I'm kind of interested. I mean, the TM1 thing came to be based on some very, I guess, complex or sophisticated mathematics that sit behind the actual engine. And I think you're kind of well known as a mathematician. in your background. So how did that kind of come to be? Were you a natural math addict when you were a little kid kind of thing? Or?
Actually, math and I was a late relationship. Prior to that, as a kid, as I think I mentioned to you before, I had a bit of dyslexia with numbers, and I had difficulty adding up numbers because my mind would wander as I was going down the column of numbers, and so that, I mean, I didn't have any problem, getting through school and doing problems and what have you, but it wasn't something that I particularly enjoyed. And then when I went to high school and I started studying geometry, which is probably the first true mathematics that you do that involves axioms and theorems. That was a lot more appealing to me. But as I got into college, really my interest was more in chemistry. I went to an engineering school that had a very broad curriculum of physics, chemistry, mathematics, and all kinds of other engineering-related subjects.
What was that school?
Stevens Institute of Technology in Hoboken, New Jersey, still there.
Yep.
And it's quite a good school, if I may say. So somewhere along the line, at that time, of course, there was no such thing as computer science, and I had a computer course, a programming course, and I fell in love with programming and the sense of power that you get from telling a machine to do something, and it does it without asking any questions or complaining. And
right. Okay. Yeah.
And so I remember having a big I had to make a decision at the end of my freshman year to either go into engineering or to go into pure science. And the father of this good friend of mine said to me that mathematics was the thing to study because with mathematics you could pretty much do everything, and they taught you how to think. And so I chose that route. I forgot about chemistry, and started taking courses in mathematics. And I never really, I'm not really known as a mathematician. I mean, I can prove theorems, but it's not, it's not a passion. And it's, it's something that I felt didn't have the practical application that computers do have. So I would say my tendency was more towards the science of algorithms and data representation and that sort of thing.
So when you were at Stevens Institute, was part of what you were learning about back then already databases? Were they talking about?
No. No, the notion of database came to exist a lot. Well, I shouldn't say a lot. Maybe a few years after I had graduated and gone to Exxon Corporation.
Yeah.
And prior to there was talk about database, but the notion of a common database for multiple applications was something that was just developing at a time. And certainly the relational database wasn't there. But it was an interest that I had, and I had toyed around with having databases that were self-describing and that sort of thing. I remember even working on something I would call a functional database, where you could define objects in this realm as functions of other objects. So there were kind of some seeds in my mind back then.
Uh-huh. Okay, and so that was something that came out of a course, like at university, or that was something that you were just kind of thinking about?
No, that was
time?
more, I would say the course that had the most influence was a course called linear algebra. And linear algebra looks at matrices and vectors and that sort of thing. So that had an influence on, certainly on TM1. But it was, and of course the computer science and algorithms, that's what I picked up in college. The rest was pretty much experience applying these things at Exxon Corporation after I joined shortly after graduating.
Right, okay. So, okay, well, so then that was your first job after graduating, was right into Exxon, huh?
Right, correct.
Okay. And so, I mean, it was at Exxon where, the light bulb moment happened, wasn't
right.
it? So, I mean, how many years after you started at Exxon did TM1 start to come into your mind?
I started in '69, and the light bulb moment came on, I would say around early '82, late '81. And I'm
right.
I don't have a good sense of dates or time back at that point.
So what were you doing at Exxon in that time from when you started till you got to that point? Like, what was the kind of your job there?
I was in a part of Exxon that was focused on computers and mathematics.
Right from the beginning.
Right from the beginning. Yes, I was very lucky that I went into that job. It was called ESSO at that time.
ESSO,
Exxon was called ESSO for Standard Oil.
Yep.
ESSO Mathematics and Systems Corporation. And one of the first things I did was learn about linear programming of refineries, where you had these demands and you had these crudes and you have these ways of boiling them into different products and so on.
Right.
And finding a way to do an optimal allocation. So that was one thing I worked.
How would you do that? Like, just out of curiosity, like, so is a lot of that paper-based? Are you doing that in computers?
Oh, no. This was done with computers. So from the get-go,
everything was with
everything
computers.
was in computers. They had a big IBM 360 that they had paid millions of dollars, and it's probably 1/100th of the power that you have on your phone.
Yeah, right.
And it was back. It was back in the day of key punch cards. So you had to write your program in 80-column cards. I don't know if you ever saw one.
Yeah,
of those.
no, I have. Yeah.
And you would submit that to the computer, and back would come either answers or a dump. A dump meaning.
What does a dump mean?
When there was a bug, in order for you to be able to find what the bug was, the machine would spit out a picture of memory. And
okay. And then you just had to figure it out from there.
And then you have to figure it out from there. At some point, we got this incredibly advanced thing, which was a way to edit your card deck and submit it. And you had a TV screen that you actually used. And it was at that point I started using glasses, because apparently it kind of hurt my eyes. But interestingly, very early on, we got a call for this IBM salesperson that was selling a time-sharing service, which essentially was something that gave you a terminal, and it was a line-by-line printing, but it was totally interactive. So you would sit there and you would write your program, and you would then run it in real time, which at that time was like unheard of.
Right. Yeah.
And I used that quite a bit for doing some of the work that I was doing that had to do with optimization of scheduling and kind of what's known, I guess, probably until this day as operations research type work, and that had some interesting mathematics in it. So
that was on a timeshare. Then you were doing that. So
I was doing that, so I was able to get a lot done because I could. I mean, it was like a difference between interacting within 5 minutes or waiting half a day. And then the whole mainframe thing was, it became very unreliable, and the system was, it was a mess. And that went on for a few years. Then from there, I was assigned to various projects that had to do with refinery information systems, of gathering data from chemical and petroleum processes, and collecting them and then producing reports. So it was kind of a.
What did those reports look like? I mean, they're paper-based reports.
The structure was very simple because it was just a bunch of time series. So you had a time series of inventory of the tanks, and you had time series of the amount of gasoline that got produced at any one time. And that information had to be stored, and it had to be, and there was some reporting things that software that was used to get the data out, and that's the thing that got me to live in Antwerp for a couple of years.
In Belgium there, yeah. Okay.
Yeah. And then, so I moved around. I got to a management position in Houston with Exxon Chemical, and again, kind of looking at computing across the various plants, and what what applications they should develop, and I had applications on in maintenance, in loss control, finding where you were losing product or.
So what led to the thought of TM1?
Okay,
like where did that come from then?
Let me get to that. So
I guess you had like a deep background, I guess, in understanding the Exxon International Corporation's kind of business and how that's modeled.
At that point, I was sort of in the periphery of Exxon, where now Exxon had a number of. It's a huge company, and it had a number of divisions, and you had production, exploration and production, and they're the ones that drill for oil and pump the oil out of the ground. Then you had to refine the products. Some of that product became chemicals, so it was a chemical company. And then you have marketing, and the ones that have the gas stations and so on. And then there was the Exxon International Company, which was sort of the nerve center that looked at supplies of crude oil from various sources in the world, and demand of products, and kind of balanced the whole thing. And it looked at transportation and managed the tankers and all that.
The 70s and 80s would have been an interesting time for all of that.
Oh well, you're not kidding. Because, and that, that's a different story. So we can come back to that. So So I got assigned to Exxon International. So I came from Houston, where I was with Exxon Chemical, and they put me right in the heart of Exxon International Company in the and what was called the Supply and Transportation Department, and
Yep.
it was literally the nerve center of the whole
whole lot.
corporation.
Right. Okay.
And it was an incredible experience. And I was in a user department. I was I was in charge of making sure that systems were running properly, and liaisoning with IT. And IT was a separate part of Exxon International.
Okay.
And this is where, so I came into contact with their planning. The system that I was responsible for was used primarily for the operations of the fleet, of loading ships and where they were and when they were discharging and all that. And it was based on an IBM real-time system called IMS, which I came to find out is still used today.
Yeah.
And for the most part, the planning side of things was done with pencil and paper. And at some point, shortly before I got there, they decided to use this IMS system and tweak it and put in a database where they could keep track of their...
Right.
Right.
To do the plan itself, at
And
least just the
then-
numbers.
Right.
Yeah.
And
Okay.
then, and it was costing them a lot of money to run.
Yeah.
And then this, one day, this woman from IT came to my office, and I can almost see her coming in and sitting down. She said, well, you know, I wanted to suggest to you that perhaps we can have a project to develop something using a database and time sharing that will do what the IMS system is doing and cost a lot less money. And that was the beginning of TM1, because I could, you know, right away I put aside my management.
Yeah, you were like, yes, you were looking for it, you wanted to do something. Okay.
And so,
All right.
so I said, gee, that sounds like a good idea, and I started fiddling with it on this time sharing system that
Yep.
that was similar to the one that I had worked with way back when I started with Exxon.
Right.
And I put together a prototype. And you know the story that
Yep.
I realized that I couldn't do it using a database, that it had to be done in memory. And when she found out that I was not using a database, we had a fight, and it went to my management, and they decided
So you
in my
had
favor.
wait, you had a fight about it because she was like, no, this has to be in a relational database.
Has to be in a relational database.
Yeah, but why was that? It was just
Well, because
sort
that's
of dogma,
how the way you did things in IT. That's the way things were done.
yeah.
And at that time, there may have been relational databases, but in fact, the database that was used, generally used at that time, was not relational. But that's not really relevant.
Right.
The fact is that it was this base and it was a database, and I realized that it couldn't be done. So
Why not? Why was this use case? Why couldn't it be in a database like that she thought it was?
Because you had to be able to change the value
Yeah.
and see the result on
Right.
the total right away.
It was a planning. Okay, it was a planning tool where you
Oh,
wanted to be
absolutely.
able to tweak it. Go
It
like.
was a cube. It was a cube
It was a
with
cube.
hierarchical dimensions,
Yeah.
and that was basically the application. The application was you had cubes with time, of course, crudes, locations, and products, and it looked
Right.
at the balance of all those, and then we had a section that was called industry analysis, and industry analysis looked at also companies, different companies.
Right.
So it looked at the whole
Suppliers.
oil
kind of thing, or what?
business, right?
Okay.
And kind of, and now that I was there at a very interesting time because that was right at the cusp of the Iran crisis,
Yeah.
and I remember that for the first time in history, the demand for oil had declined, and people were like in total disbelief. And
Right.
Exxon, who up to that point was supply limited because of the turmoil in the Middle East and all that,
Yeah.
they had been buying all this oil from Saudi Arabia and parking it in tankers off the coast of Venezuela, kind of like inventory, but on ships.
Yeah. Right.
And then all of a sudden the price of oil broke. It actually had, it had gone to, I forget what the numbers were, but it was an astronomical 7-fold increase in price.
Right.
And finally, price had an effect, and people started conserving, and they started substituting other things, and the demand came down, and so all of a sudden, all that inventory that was sitting there went,
that was like where
devalued.
fuel efficiency came into cars and things, right? Where they started, people started really like rating that, right?
Right, and and that had started before with the crisis after the, I guess it was in 73, 74 with the Israeli war.
Okay.
Anyway.
But getting back to it, actually, so that original brainstorm, before it was even TM1, that you ran on the, while you're still at Exxon, so that the features of TM1 that were there from the beginning were, it was a dimensional structure, it was cell-oriented, I guess.
It was
hierarchical.
It was cell-oriented. You could change. I mean, essentially, was a multidimensional consolidation engine.
Right.
There was no spreadsheet. So effectively, people would use that to tabulate enter their plans from data that they currently had on paper spreadsheets, and put it in and be able to look at the totals, and also to have a history and compare it to prior period, and which
so it could remember all of that too, which would have been huge.
Exactly, remember.
Yeah.
And interestingly enough, there were, the people that worked there were like, somebody used the term number mongers, and they could remember the plant. They had photographic memories of all the numbers that had been used in the prior.
It's like a skill that's probably not as necessary anymore.
Right, exactly.
So
that's good.
So that's interesting. So like people would that's like the first time where like a finance person would be sitting in front of a computer and kind of go, well, what would happen if the price changes even more or drops even more next month or something like that, and would be able to rerun a plan on that? Is that the kind of stuff, or was it more just
no,
supply
because
kind of
there was
chains?
No like price. There was not a question of price sensitivity.
Okay.
That had to be done. That had to be done manually in a. But what it did is it organized the data, and it gave you the security of having consistent data.
Yeah.
It gave you a history. But other than for consolidation, the computation capability or the modeling capability just wasn't there.
Right.
Nor really would have been. I mean, the hard questions, like for example, the whole question of inventory of because essentially you had supply, you have demand, and then you have inventory.
Yeah.
And the inventory goes up and down, but you don't know how much there is. You don't have a measure on an industry basis.
Sure.
Exxon knew exactly what they had, but
yeah, right.
but on an industry basis.
Okay.
And there was the inventory in people's gas tanks, and that, by the way, had a big effect when the oil the lines.
Right.
All of a sudden there was no gas anywhere, and the reason was that people, instead of what they normally do, which is they drain their tank to maybe a quarter,
Yeah.
and then they fill up again, they kept it full all the time. So all that demand essentially sucked out all the supply, and that's what caused the gas lines.
Right.
And of course, that fed the insecurity of
right.
Of having your tank full. And
right. Okay. Maybe we should kind of step forward a bit. So at that point, you had the brainstorm for TM1. I mean, why leave a great job at Exxon and basically do a startup at that point?
Yeah.
How did that come to
be?
See,
there was a confluence of things that took place, and it's kind of a very sort of fortuitous. When I got this and got it going, and it was a big success, because up to that point, these people had to keep all their numbers in their heads or on paper spreadsheets.
Yeah.
They loved it. They were saving a ton of money because they weren't using the mainframe system, the IMS system. I said, well, gee, this is a business opportunity. What am I going to do? How can I commercialize this?
Uh-huh.
So I looked around for a commercial time sharing service, and that would have required me to come up with a deal with a time sharing company. I spoke with a friend that had developed such a system in this, using this time sharing company called National CSS.
Okay.
And right at the time, the IBM personal computer came into the picture, and I came in contact for the first time with a spreadsheet. And I said, here it is. This is clearly what I need to do. I need to get myself a computer and park it in my attic and start developing. And I could do that with a very modest investment. And it was at that point then that it became clear that the analysts at Exxon International would have benefited from having a spreadsheet. And in fact, I developed a little spreadsheet on the time sharing system, and they loved it. So it was clear that was the way to go. The other factor that kind of came into that confluence was that the oil business was going down the tubes.
Right.
And what had been essentially sort of an unlimited
boom
growth.
Times. Yeah.
And people, these were kind of inflationary times because of Jimmy Carter and the oil crisis and all that. We were getting incredible percent races every year. All of a sudden that was going to disappear, and the future
Right.
was not so bright. So it was a clear option.
Yeah.
Now
I mean, it was still a big call to make, though. I mean,
Yeah,
for you, right? I mean, you weren't single or anything at that time either, right?
I had a baby. I had a kid. Adrian was 4 years old, and
Yeah, right.
Daniel was, a baby still.
So that's a pretty big call at that time.
Yeah, it was.
And then
it was, but it was
a great call, by the way.
yeah,
Thanks for that call.
yeah. But it was always very clear in my mind, and I had some moments. Well,
What was clear in your mind?
that this thing was going. Well, let me backtrack a minute. My original vision was that we would get some money and would put together a small private placement to kind of launch the company.
Right.
And that the moment this product came out in this show in June of '84,
Yeah.
that I would die in the
mob.
In the mob. The mob would.
What happened at that show, actually? I don't know if I've ever heard. Was
nothing.
Nothing?
Very little happened.
People ignored you guys at that show, or what?
Well, not totally, but pretty much. And it was a hard reality at that point. And that was the first time that it became clear. Whereas at Exxon, everybody saw it and they loved it because that's what they did all the time.
Sure, yeah.
At
So
Exxon
these people,
International,
they just didn't see it right away when
this
you were
was,
talking.
this was the general market, and they knew about spreadsheets, and here was something that was far better than a spreadsheet, and and nobody did anything. So, it was.
We're still dealing with that today, by the way. People just look at it
Well,
and
sure.
don't immediately just go crazy
That's right,
for it.
but
they don't
now-
understand it right away.
But the same mechanism that was working at that time is still working today, which is that you have some people, a small percent of people that have the vision and see it and can see and they adopt it and they bring it to fruition, and that's kind of what kept me going, because I remember early on there was this guy who was the CEO of a small insurance company, and one of my colleagues' wives worked there, and somehow the colleague presented to him, and he looked at it and he went crazy, and he just did all kinds of models with TM1, and wound up selling the company based on models that he had developed with TM1. So
nice.
It was
So
clear.
you knew you were onto something there.
Yeah, exactly. But it was a very slow kind of word of mouth. You would try all kinds of ways to get into people's heads, and it was truly hard.
Yeah. Well, I mean, I guess this is fast forwarding to like today. It must be interesting to see a bunch of people in the room this week, kind of all talking TM1 and how they're using it, and the fact that it's still being further developed, and innovative ideas are still coming out. Right? So.
Yeah, no, it really is. It really is. And I spoke about this when we had
when we had our conversation here in the
conversation. Yeah.
Mm-hmm.
That this mystery thing, this kind of intellectual hurdle, helped keep TM1 from being overwhelmed by competitors.
Yeah.
And
it's kind of been incubated in some ways.
yeah, exactly.
Kind of,
it has had an incubation of over 30 years now, and it just and it keeps on growing, and yet the hurdle, the intellectual hurdle, can work in good ways and in bad ways. It works in good ways in that it keeps competition away. In bad ways, for example, I get concerned about the degree to which IBM truly understands TM1, and the people who currently are running the show at IBM understand it. And perhaps it's unfair, and I shouldn't be talking because I really haven't had a chance to interact with these
the people who are at the core of the development. I mean, we're talking with Hubert and other people who are like looking after the server. They certainly know what's going on there, and they've done a lot of really good stuff in the last year. So
they do, and
that's good.
And I'm encouraged by that. But I'm thinking of it from the standpoint of business development, and to what degree do you want to put an investment, and to what degree do you really understand the market and can put around it sort of peripheral, call them applications, call them user interfaces, things that work around and kind of help the user get the benefit. And like you guys do, CubeWise does great stuff because you're there.
I think that's kind of the way it's worked, right? Like, I mean, the partner channel has always been really huge for TM1, right? And a lot of it's been driven by the partners and not always necessarily the vendor in terms of like the innovation going on with the customers.
But you would think that IBM would look at the stuff you guys have developed and buy it in an instant and take it to the world.
Yeah, but
you would think.
For what it's worth, at least they really support the partner channel, and one way of doing that is that Hubert and the server team built the REST API, which has been a huge improvement to enable partners not just to be able to deliver solutions like from a consulting practice point of view, but actually deliver new software innovations and being able to add technical solutions as well, which has been
but that's
big step forward.
Again, that's from the technical point of view, and it's great that that's happening. But the question is, from a business development point of view, recognizing the importance of making the product more usable and more adoptable. And the extent to which that is happening, and I guess I have a lingering impatience, perhaps because
well,
it's getting late in the day for me.
Yeah, right. Okay. All right. Well, yeah, but for what it's worth, like like this organic growth is still happened from day one is still happening today.
It's still happening.
Last year was a great year for TM1 growth as well, right? So this sort of organic growth keeps happening to where it's funny to say that you still have this. I still have this feeling that TM1's kind of this underdog, but it's actually sort of a dominant force in the planning market, I guess you'd say. Like it's, and so it's kind of quietly become like the biggest planning tool around.
But my dream of the explosion and having the mob scene and so on. It's
having a float in the Macy's Day Parade or something.
Hasn't.
Yeah. Okay. Well, just a couple of rewinding back a little bit, maybe a couple more questions about that people are probably interested in. I mean, to kind of do a quick, we'll call it like a timeline, right? Like, I mean, the original thing that you did had the the ability to consolidate data in the hierarchy. So right from the beginning, I
Right.
guess it was like you stored data at the base level, and it would calculate on the fly the
Right,
consolidations,
absolutely.
which was
Yes,
key, right?
yes,
And it had dimensions,
just
and
like
the cube
exactly
style.
what it does today. The only thing that it didn't have was rules.
Okay, and maybe a couple other things I'll mention as well. But like rules was a huge thing. So when did rules come in?
I'm talking about in terms of the data-based data structures. It didn't have TI, but TI is kind of an external thing.
Yeah. Okay. So you're talking about like the core functional database
right.
features.
In terms of the structure itself, it was the cubes, it was the dimensions with the hierarchies and the consolidations, and the weights and the strings that were there from the beginning.
The strings were there from the beginning as well,
Yes.
to be able to write. People wanted to be able to write strings and comments right from the beginning.
Right.
Okay.
And it was clear that you needed that. So
Yeah.
all
Okay.
of that is from the very beginning. But
Yep.
the modeling was done in Excel. Essentially, for example, if you wanted to calculate a percent growth, you couldn't do that in TM1. You
Yep.
had to do it in the spreadsheet, and the spreadsheet let you do that. But as I didn't mention that the spreadsheet that we had when the product was released was a proprietary spreadsheet
As your own
because I
spreadsheet,
couldn't
yeah.
have it interact
Yeah.
with, I couldn't have both things have a commercial like Lotus 123 or VisiCalc
Yeah.
because of the limitations of the PC.
Yeah.
And
You
that
couldn't just have an add-in back then.
you
It just-
couldn't,
yeah.
right, that's right. And that didn't happen until the server became client server.
Yeah.
And then you could have other spreadsheets be clients, and that helped open up the market
Right.
quite a bit.
I mean, that's a big deal, the client-server part of it, because it adds the massive collaboration aspect of it. Makes it
Well,
like,
yeah,
it's a way more
that-
collaborative
exactly,
platform then, right?
Exactly. I mean, that opens up
Rather than an individual spreadsheet style.
Right, exactly.
So, yeah.
But so going back to the modeling had to be done in Excel, and then there's the story of somebody in Germany said, "Well, gee, I'd like to be able to do this kind." Somebody asked for being able to do nonlinear meaning calculations that you can't do using a dimensional model. You have to take. So I'd say
They wanted to do that in TM1 rather than in the spreadsheet. Is what
to
you
do
mean.
that exactly. Do it in TM1 rather than in the spreadsheet.
Yep.
And I say, oh, that's easy. We'll just
No big whoop. I'll whip that up over the weekend. Yeah.
The cell is a function of these other cells, and there it goes, and off it goes to Germany, and it comes back that the consolidations are not working, and that was
Right.
that was the moment of technical panic.
Right.
in TM1.
Yeah, you thought you'd maybe hit the wall in terms of what was
Yeah.
possible.
Well, no, I mean, at that point, it was clear that that I had to find a solution to the problem, and I had no idea where to start. So I kept, I had a few nights of waking up at 4 in the morning in a panic, and finally, the infamous feeders
yeah.
came to me and saved the day.
Yeah.
So that was the one big step change in the capabilities of the model of the database itself.
Yep.
But there's the client server, the TI, the API. The original API is one of the things that I'm not very proud of because it's incredibly complex, and that has been cleared
That's
by
fixed
IBM.
now. Yep.
The the multi-user, the concurrency
Yep.
thing is something that at some point became an issue after my time, and it took IBM a while to fix it or get it right. But now that
They definitely have. It scales to like hundreds and thousands of users now, like, and it does well. So they've nailed that.
So yeah, so I'm very pleased with the. I mean, I'm kind of amazed at the longevity of the little model that that was done back from from the very beginning, and it's still other than for rules,
yeah,
still works.
I mean, the core engine itself is there isn't another engine that's that somebody has thought of or a way of doing it that seems to be able to outdo it. People have had a lot of ideas of front ends. How do I provide a user interface that makes planning or financial reporting or modeling interesting, but the core, engine itself still is unsurpassed.
Yeah,
so
and
some satisfaction in that, isn't there?
And yeah, there is, and there is a lot. There is a lot. I think somebody asked Hubert a question yesterday about, giving more details about the innards of the engine. And the fact is that there's a lot of stuff in the engine that, other than the developers, nobody knows about. That makes the difference.
Sure.
And there was some reference to it. I made a comment. You were sitting next to me and started talking about the memory allocation.
Yeah.
That is fundamental to the functioning of TM1. And if that wasn't done right, it would have, it wouldn't have supported the performance.
And that's why the incubation period maybe was quite good, where you were able to sit down and like make sure this stuff was done right, and you were able to actually, you weren't just kind of going at the whims of some like, we have to go do this sale over here that's like more important than like getting it right, or am I misunderstanding that?
Actually, well, yeah, in a way, exactly, and you can't. I mean, you know that the diagram of the circle. It's very much in the nature of things that you can't foresee all that people are going to do with a product.
Yeah. And
you can't foresee the evolution of technology and how it can affect the product.
Yeah.
And it's a good thing that it's been able to grow along both the dimension of technology, things like 64-bit memory and the web and local area networks and all that, and also the dimension of the users making bigger and bigger models. And one that Hubert talks a lot about is the try thing, the way the data is organized. And that wasn't the original design. The original design had a much simpler approach, and I think I've explained it to you. You had just an array of pointers at each level in each dimension, a hierarchy of, you had a tree, but it was a simple tree. And then as things got bigger, they got sparser, and as they got sparser, it became impractical to do it the way it had been done before, so something had to be done. So that, that was kind of an interesting thing to do. The way that rules are assigned to cells and the way that it knows what rule to apply to each cell is not a trivial thing. And that had to be done right as well.
So is there anything that, out of all those,
regrets?
No, I'm not saying regrets. Like I was going to say, thousands of, small decisions you make along the way in terms of building a product like that. And, sometimes you're probably battling other developers or or people in sales or whatever, or marketing as well. Like, is there any particular aspect of TM1 you're glad you stuck to your guns about that you can see had a lasting impact?
It really was never a matter of debating or getting pressure from the outside, because typically,
Yeah.
it was me and in an empty room thinking about it. It wasn't. I mean, the problem was clear. The demand, the
Right.
need was clear, but how to go about doing it was the question, and
Yeah.
that.
So the core design from the beginning through the Applix days and so forth was
Yeah.
all your thinking.
Yeah, pretty much. Pretty
Mhm.
much.
Okay.
And then, and in terms of regrets, there
Okay.
is user-defined consolidations, which has been
That's a
plague-
regret. So what part of that was a regret? Because the actual functionality is kind of cool. People liked it.
Yeah, the functionality is kind of cool, but it doesn't really fit into the model, and it could never be done properly and reliably. So it's been a source of grief for the developers, and now finally with
Yeah.
the hierarchy, so that that gets resolved, hopefully for good.
Okay. Maybe kind of just one final question, and then we'll call it a day. Just the conference itself, I'm kind of interested now, over the years. I think the first time, I got a chance really to interact with you for real was when when I kind of nervously called you to ask if you would come to our conference in Sydney, Australia years ago. And that was amazing for us when you said yes and you came to the conference. And I remember you kind of talking, how stimulating it was for you to get a chance to talk to the users and get feedback and understand that, right? And so I know you've attended a lot of these conferences over the years. I mean, what's your thinking? What keeps bringing you back here? What is it that's interesting for you about the conference itself?
I mean, I certainly I'm interested in seeing what people are doing and what problems they're solving, and the scaling, the whole idea of what are the scaling challenges, which as I mentioned, was kind of the driving force behind a lot of the incremental improvements of TM1. It's also interesting to see what new features are being added, and it gives me an opportunity to kind of needle our friends of IBM.
Right. Okay. There's a chance
to the extent
to talk to them a little bit.
Right, and so
Nice.
it does
Can you
that.
make sure you're blocking the
Oh,
microphone?
the mic.
Sorry. Yeah.
So it does that. It's always nice that people, and I'm only human, and it's nice that people like to take a picture with me, and
Yeah.
it's not
It's nice.
that
Well, definitely people appreciate you.
I don't,
So.
I don't particularly live for that, but I do appreciate it, and
Yeah.
it's very, as much I like to think that it's not important to me, it is.
Yeah. Well, I can say it's happened again a couple times at this conference, where, people will say, man, we really owe our livelihoods to Manny, and people really appreciate that, because it's not just that the technology is good, it's that there's just a large community of people in the world who just really enjoy working with it, right? And it's just very satisfying. And so, all those people really appreciate you coming here, I guess, and getting a chance to, I guess just maybe meet you and talk to you about that, because it really means something to people. Right?
Yeah.
So.
No.
So thanks for that, Manny. Like,
no,
on behalf of everyone
is,
out there, all the TM1 community, like that's.
It is, yeah, it is very. I mean, it's you talk about being realized, but let me not go there because I'll get mushy.
Okay. Yeah, I don't want to be like Barbara Walters
And I
or
don't.
something.
Yeah, if I get mushy, I
Right.
don't do mushy too well.
Okay. Well, Manny, I think it's thanks for spending time with us here at the conference.
Thank you, Ben, for inviting me. Thank you for the work that you do. I truly have a debt of gratitude to you for the work that you do with TM1, and
Right.
You're probably the number one force keeping the flame alive.
Well, all right. I appreciate that, Manny.
Heartfelt.
There's just a community of people out there who love TM1 or just want to keep it alive, right? So that's all we're trying to do with these kind of events and stuff.
You have to do what you do, and you have to do it right. As I've told you a number of times, you're doing it right. So,
right. Well, I appreciate that, Manny, and thanks for spending time on this broadcast and the conference. Appreciate it. See you, Manny. All right. I guess that's it. So I guess we'll sign off from the conference this year. I hope everyone liked this and hope to get some of your feedback on these broadcasts. Thanks.